So we are recording. We did this U cross V business. I can't record that part. Like I don't have it written down. Can you tell me what the answer was for U cross V? Anybody confirm? Confirm that one. 10, -5, -10. Thank you. Because yeah, that was of course. Oh, it doesn't. It does not have it. These are the after we're doing it. +10. Okay, I'll do +10. So is that confirmed? Thank you. I'll take the picture over your. Sorry. I love your handwriting, bro. Your handwriting's so good. I'm just playing. I'm playing. Okay, so we got this U cross V, and we did the length was 15, and the reason why was because I did the square root of the squares. Am I right about that? I'm just kind of like recapping on what we were doing. 225 made the 15. Awesome. Yes? Good? Okay, so all back to where we were. Now they say find the direction of it. And when they say direction here in my math lab, they're wanting the unit vector. Okay, the unit vector. At least that's what I'm thinking. So what I need to do is take my values and divide them by the 15. And so I'm going to take 10. I'm going to do that, yes. The 10, -5, 10. And I'm dividing it all by 15. And you can see quickly what the answer is going to be, right? 2/3, -1/3, 2/3. And we can verify with the answer over here now. See? There it is. So we're good there. So that's definitely the way they're wanting to go with that. Direction for them in my math lab means unit vector. Okay. But we had done unit vectors. That's not a big deal. So they're trying to be silly with this here. They're saying find the length now of V cross U. I don't personally want to do that whole huge cross product again, especially when it looks like it's practically the same. So let's just talk about this for a second. Kind of interesting. When I do 2 times 3, we get 6. But what if I do 3 times 2, I get 6. This, when you can do that, it's called commutative. Commutative. That's good for the linear class, by the way. I'm just going to tell y'all. So commutative means that you can swap them out. Okay, so we could swap them. That's not the case with cross product. So if you had U cross V, it's not equal to V cross U. Okay, so that's one that's non-commutative. So I'm going to write that non-commutative. So that's the fancy words. So like I can't get the same answer than what I was previously getting. Kinda. So as a concept, if you don't mind, I'm going to scroll up for a second. Yes, it is. That's why I was using a dot here instead of a cross sign. That's exactly right. Yes, so U dot V is equal to V dot U. Yes. Very good. Thank you for reminding me of that. So let me go for a concept here. So we had this is U cross V is this way, and there's the same picture here, but now it's going down when you swap them. But it's the same picture, the same thing, same concept. It's just, I guess you say it's like negative. And that's how we should process that. Although I won't say this always happens in non-commutative land, for cross product it always happens, that I just take what I got and I make it negative. So this is super easy. When I do this now, V cross U, it's now going to be -10, +5, -10. That's it. Very simple. Just make it negative. And we're going to verify here in a second, okay? So what if I wanted to find the magnitude of that guy? What do you think I'm going to get for the magnitude of this thing? Same thing, 15. So let's verify that we're doing the same process here with the instructor side. Same number. And you can see it's the same numbers again, just they're negative now, right? Again, that's not literally V cross U. It's just that we had the unit vector, blah, blah, blah. But you get the idea. Yes. Yeah, because it's always just the opposite direction. Yep, opposite direction. Cool. I'm sure there's a property somewhere in the ebook about that says it's negative of that, but cool. Just concept stuff. That's all. Awesome. I'm gonna scroll on if y'all are ready. If not, you tell me. I'm here for you. Scroll, scroll, scroll. All right. It says find the area of a triangle. Ooh, I love it. So, quick question: do you have to use, I don't know, calculus to do that? Not really. Can you use geometry? Probably. But then all of a sudden they ask for unit vector perpendicular blah, and basically they're wanting u cross v again is what they're wanting here. So yeah, might as well do what, the fancy version now, since we're going to have to get the answer anyways, if that makes sense. So let's go back up for a formula. I'm going up here and I'm looking for formulas for a triangle. Okay, well that was the start of the section. I don't see nothing. I see area of this thing, but that's not a triangle. Oh, but wait. What did I just do to that thing? Cut it in half. And so if you take whatever we have here, you're going to say divide by 2, and then you got your triangle. So I wouldn't say write what I'm writing because that looks confusing. But the idea, though, is triangles you're just cutting it in half, right? So let's use this formula. I'm saying magnitude of the cross product. There you go. So let's do that. I'm going to find the cross product, find the magnitude, just like we did here. And actually, you know what? I want y'all to do that. Oh, okay. Pause. I want y'all to do cross product, but then we haven't done one today. Would it be okay if y'all do one today? But or do you want me to do the first one of the day and then y'all do the second one? First or second? Which one do you want? Second. Okay. Well, you're the first one to say something. You want your word set. You got to do it fast, faster than James. So I need to create 2 vectors in order to do a cross product to begin with. Let me first, before anything else, I'm going to draw a picture so I can at least see what's going on. So -2 or +2, -2. And so I got a point right there. And then we got something in the Z land, right? Kind of weird. Notice though that it's 0, 0, and 0, 0. Yeah. So it's kind of like it's sitting right here, kind of, but they're above the page or below the page or something like that. So let me draw 3D. Here we go. Let's do some 3D action. I have my first one is at, oh, look, I did 2, +2. Bad Chad. -2. Okay, fine. So, sorry about that, guys. Right? Isn't that a -2 right there? That was my bad. -2, +2, +2, -2 right there. So there's my first point. This is P, okay? And then this is 0, 0. It should be right here, but above or below. Notice -2 on Z is going to be below, so I'm basically going down 2. I'm right there. That'll be my Q. And then I'm going to go up 2, and this is my R. And I'm like, okay, well, connect them and find the triangle. And you're like, it's kind of gross, right? It's not really that easy to see what's going on with that one. But technically, there is supposed to be a triangle here. What I want to do is redraw it. So then this will be X, Y, and Z. And so here, 1, 2, 1, 2. And then I'm going to go down some. And I'm going to go up some. P, Q, R. So you can, oh, no. I want to undo. Oh, I want a new color. Okay, here we go. We'll do green. You see the triangle now? Well, it's 3D. You almost have to kind of look around it to kind of see what we're looking at. So we're looking at this triangle, and I need to find 2 vectors. Now I have a question for you. Which one do you want as the origin point, the first point, the point where we're starting our vectors from? You give it to me, P, Q, or R. Which one do you like? You like P or it's Q? You like Q? You like Q. Let's do Q. And so Q is going to be where I start my vectors from. Watch this. So Q up to R, Q out to P. Yes? Those are going to be my two little vectors. And I go math, 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 get the answer. Cool? So let's do that. I'm going to do Q to R, and then I'm going to do Q to P. Do you remember how this works? What's the formula for a vector? It's a very simple one. Yes, subtract. What? Well, it's subtract. It's just subtract. But what are the words that I use? Terminal minus initial. Yeah. Terminal minus initial. Terminal minus initial. And so therefore, in a way, I'm saying it's kind of like R minus Q here. Right? And same thing here, I'm going to say it's P minus Q. That formula, I guess you can say. And if you do that, R002 Q is going to be 0, 0, negative 2. What do I get for this guy? What's my 0, 0, 4? I know, right? Yeah. And then this guy, we're going to have 2, negative 2, 0. And I'm going to minus, I'm running out of space, 0, 0, 2. What's my answer for this guy? Sweet. Yeah, I think so. So this will be, let's call this one my U vector. Let's call this one my V vector. And then we're going to do some cross-producty stuff. I'm running out of room real quick. So what I want to do is get up my blank page and just start. And you said that I'm doing the first one, then y'all are going to do the second one, okay? So this will be the first cross-product of the day. Y'all okay so far with what we're doing? Yeah? Good, good. Okay, so let's practice one more time with this guy. I've got 0, 0, 4, and I'm going to cross with 2, negative 2, negative 2. So I'm going to do my speedier version because I kind of already know what the letters are going to be, okay? So in a way, I know that I'm going to get a 0. That'll always cancel. And then I'm going to get something K. Sorry. See, I'm already messing up. Erase. K. And then I'm going to get something else, negative J. Negative J. It's probably better with parentheses, but either way. Down here, I'm going to get something with a negative K. 0. And then something out here with a plain I. Finally, down here, plain J. Negative I. And then a 0 again. So I'm kind of like setting it up and getting it ready for whatever numbers I have to put in there. I'm going to pause on that for a second. Make sure that y'all are okay with that. Now, like, I'm going to tell you right now, between you and me, this is taking a long time. To find the area of a triangle? You know what I mean? There's surely a better way to do this. And there is. We're trying to do it this way. 1, for practice, but 2, because they're actually asking this other thing right here. If they didn't ask for this other thing, I'd probably just do geometry or something. But we're kind of stuck with it, and that's okay. All right, here we go. 0 times anything is 0. 0 times anything is, and 0 times anything is, and like we can knock these things out. You know what I mean? Like when you have it all set up, boom, 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 boom. This should be no problem. Let's do the next level. So this guy, 0 times anything, 0 times anything, and then 0 times anything, 0 again. I like this problem. Yeah. Okay, so actually like the real math now finally. Maroon, I guess. So I got my, oh no, I want my maroon. Okay, there we go. I got my 4. So 4 times 2 is 8, and then 4 times negative 2, and then finally, blah, 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 it doesn't matter, it's a 0. And so I don't need any of this. Like that's basically going to be my answer. What would I actually put for my answer now? Be careful. 8, very good. And 0, yeah, because there's just nothing else there. Notice that right here, 2 negatives make a positive. Yep, very good. Very good. That was a little small piece in there to watch out for. All right, all right. So to find the area of a triangle, I need to find this magnitude. Cut it in half, we're done. So we're almost there. So here we go. I'm going to say just magnitude, square root of the squares. You don't have to put the 0, but there you go. 64 plus 64, square root of 128. And that should be close enough. So again, my area would be perfect, over 2. There it is. That's my official answer. There we go. I'm sure that it actually turns out to be a nice number. You know, at least somewhat nicer. What do we got on the instructor side? 4 square root 2. Sounds about right. Cool. Are we okay with that? Rock and roll. With the air guitar. Put it back. So it says now, which of these would be that unit vector perpendicular, blah, blah, blah. That's that U cross V stuff. You help me. What do you think would be a great choice here? Looking at the options, which one's the best choice? No more math. Don't do math. Just think about it. B is excellent. Yes, I love B. The reason why? Because we have an X component, we have a Y component, and what's my Z? 0. There it is. That's exactly what I have. And X and Y are the same number, right? That we don't have 2 different numbers in front. Like there's a 1, there's a 2. Mine are both 8 and 8. Cool. Yep, so that's it. You got it. Cool. So I did one. Now y'all get to do the next one whenever that happens. So that'll be fun. Okay. Good. Scroll on. Here we go. All right. Find the volume of the parallelepiped. So yeah, sorry. I was looking through this before class, and I realized that I don't have that formula. So let me show you what's going on. What is a parallelepiped, right? So if you go up here, this is a parallelogram. A parallelepiped makes it into 3D. So I went to the book, and I had to go and find it. That's a parallelepiped. And so this is the formula for the volume. It's similar, but you can see there is an extra element in there. So let me write that down. And then, so this is the parallelepiped. I can't spell it, but you get the idea. So the volume would be the magnitude of U cross V, but then I think it's times the magnitude of W. And let me just verify that we're doing that right. Oh, look, it's the cross product, and then after all that is the magnitude. So I'm off by a tiny, tiny bit. Hold on. Almost there, almost there. So magnitude of U cross V, and then dot W. That's how they're wanting that one. So that's the formula for the parallelepiped. Sorry. The workbook isn't perfect yet. But there we go. So I want to use that formula for this one. In fact, I want you to use that formula on this one. So yeah, let's go down here. Again, a parallelepiped is just 3D. We're looking for 3 separate vectors all coming from the same origin point in a way. You mush them together, and there you go. You get to pick what your U and V and W are. They're all just arbitrary. So you pick whatever's easiest for you. Okay. Go. Yeah, I'll even write them with little alligators so that I feel better about myself. Again, you can choose whatever one you want to be your U and V and W. But again, the formula is magnitude of U cross V dot W. That's your formula. I've not been doing a lot of arrows on top of the letters simply because it gets a little messy. I normally on the board I have a lot more dexterity, but with this tablet it just starts to muddy real quick. I can't erase it with my fingers very easily. So I've just been kind of just doing the best I could there. And y'all can come to the board if you want. I mean, that's totally open. I even erased one side. Do it, bro. Yes. You have a marker down there? You got 2 markers? You want 5 markers? I got markers. I love board time. This is how I get my YouTube content up. Just a lot of blank time. Yes. The hard part's just going to be that cross product. The rest is. I really wish I could pause the video somehow, but I just don't think it works like that. Edit? Nah. That requires work. Please. Yeah. It's a fancy eraser rag thing. You're doing U cross V, like straight up. Okay. Don't look at what I'm doing. You do you. That's a J, not an I. J. This is an I. If y'all want to like talk about it while we're doing it, I'm just kind of getting it all ready, I guess. That's innovation. I use plus signs, he uses commas. It's all incredible. Oh, of course. No criticism here. You're good. Okay. I'm just doing my own thing up here for a few minutes. We can talk about it here in a second, of course. 0 times anything is 0. I got it right. I know you're good. So I'm worried about me. Yeah. Excellent. Good. Yes. I have no idea if I did it right, but I got some. Yes. I should have. Yes. Just tack that on there. Yeah. Sure, it's fine. Well, no, I had a -4 to -8. I just forgot the negative on the top. You're close. You're close. I think it's this. So, you got. I like the letters, of course. Those are all very good. K. That's a negative K. Unless you're cool with that. Unless you already did it. Kind of combine them together, I think. Yeah. But we'll see. We'll see. I's, zeros, of course, is good. Okay. So 4 times 4 we don't need. 4 times this would be a -8. Perfect. 4 times 1 is 4. Very good. And then we got 1 times 4 is 4. Oh yeah, I understand. And then 1 times whatever doesn't matter, 0, and 1 times 1 is 1. What you got? Yeah. And then the rest are zeros. So yeah, finish it up. You got it. So what are your eyes? The only thing is that we normally do J and English language stuff, but you're good. Dyslexia. No, that's good though. That's good. Good math. Good math. I love it. Very good. Actually, I'm gonna talk with this. Thank you. Good job, Ryan. I like it. I'm tethered, right? I'm tethered. I could do this thing. So I'm gonna look like real quick. You did, and you did. I already know what you did. Yeah, I'm gonna look ahead here a little bit. Advanced math, and then so I'm seeing it 50-50 thing. It's really funny. 50-50. See, some of y'all do the up down like I do, and some of y'all are doing the side by side like Ryan was doing. So that's kind of interesting. It's up to you. One thing I'm gonna have to take this off. One thing if you're doing side by side, you can foil it like we do side by side ball foiling. Is one, two, three, and then 1, 2, 3. And this what helps me because I'm used to doing the X's. You know what I mean? So if you're doing side by side, maybe do arrows, and we kind of make sure you're in the right place. If you're doing up down, up to you. That's what I do is up down. But yeah, good, cool. So we're all learning different strategies, techniques. I love. But you finished it, I think. -12, and I'm gonna dot it with the other guy. So 1 times the 4, -4 times 0,
and then negative 12 times the 2. Negative 24, very good. So negative 20 is that. Now, they're wanting the magnitude of that. Oh, wait, never mind. It's absolute value now. What's the answer? Yeah. Now let's confirm with the instructor side. We got 20. All that for a 20. That's a lot of work. That's okay. 20. Notice that, like, it's just absolute value or magnitude is almost just synonymous. They just flow with each other, right? One is a single dimension. The other is just multiple dimensions. Same thing, though. Same concept. Cool. Any questions on parallel pipettes? Great. Well, parallelogram. I don't know about the pipette part. Yeah, it's maybe thinking 3D versus 2D. And then parallelogram, parallel pipette. It might be Latin. I don't know. All right, so y'all did one. Now I get to do one, right? Or maybe y'all can help me. So it says, find the magnitude of the torque exerted by force on a bolt this much, this much. Okay, hold up. So there's probably just a formula for that, but I'm guessing the answer is a cross product. Let's go back up and see what we got. So torque. You got torque formula anywhere? I don't have one. So it means cross product then. I'm just going to tell you. It means cross product. So we're going to cross product this guy. And then it says find the magnitude of it. Okay. I think there was a similar one down below. Do we have one with a wrench somewhere? Oh, this is the wrench one. It's just... Okay. So there we go. There's the wrench. Yay. So yeah, we're taking a wrench and we're trying to apply force to it. This is right hand rule once again. So I can't show that here. I'm going to take. So wanting to do my right hand, okay, and I want to start with this, and I'm going to go in the direction of where you're going right there, I guess. So yeah, but that's against the bolt in a way, aren't you? Have y'all done bolts before, or screws? What are we doing if we do this with it? You're tightening it. Yeah. Isn't that going into the board, into the page, right? So that makes sense. That makes sense. So I guess that's why screws do what they do, right? We got our screws going that way because it makes sense to us now. So yeah. We're going to do this and then cross that and then get the answer. They only have magnitudes though. So I kind of get worried about this. I wonder if there's a quick version with like a sign or something. I'm guessing just as a random guess here. What if the answer is 4 times 36 times sine of 45? I know this would be so silly, but maybe you just roll with me for a second. Because there might just be a simple version and we just walk away from this. 4 times 36 times, what is the sine of 45? Square root 2 over 2. But y'all are in the radian, I know. All right, yeah. I was looking at y'all kind of funny for a second. So in a way, I'm guessing it's 72 square root of 2 because, again, that was the, let me just verify here again. If I did that, it's basically like saying 144 square root of 2 over 2. Those combine to make the 72. Okay. Now, let's just see if that's the answer. That would be really funny. 6 square root 2. We're not quite there. But we got a square root 2 in there. I feel like there's something I'm kind of missing, right? So, you know what? I don't have a formula for it, so let's go look. Let's go look to see if there's an easier torque formula that I just forgot to put in there. I know that we could do the cross product, but is there something easier? See, look. We got something going on there. Let me kind of look around a little bit more. See, torque is cross product, right? But they're also saying you could do magnitudes times the sine, okay? So we're getting somewhere. I'm just missing something small. You know what? I have it. Yeah, the n is telling the direction. So for us, technically, it'd just be like -1. But again, in the end, they're wanting just magnitude here, which is happy news for us because it's just a number. Yep. Yep. Do you see it? Come on, tell me. You're smiling. I know you know the answer. Why is mine wrong? Is it because we can account for it? It's going that way, like the angle 45 degrees is that way, so no. Okay. Too complicated. Too complicated. Okay. Yeah, this is easy stuff. There it is. There it is. It's inches. What are they looking for here? Are feet. Oh! I know. We built this rover, we sent it to the moon, and it crash lands because we didn't convert. Yeah, I know. That's that's a thing. So 4 inches is how many feet? 0.3, so basically a third of a foot. Isn't that correct? Like, let's just verify. I'm gonna verify. So we got 12 inches, and we're going to divide it by 4, right? No. It's 4 divided by 12. That's right. If I could just type that. So yeah, one third. So we got 1/3 feet, and then foot pounds. So 1/3 times 36 times the square root of 2 over 2. And I'm just going to do the number math, if that's okay. And then yeah, times 1/2. There it is. We got it. So that was wrong only because of a conversion. Right. So when you're looking for the magnitude of the torque, I guess you could say like magnitude of U, magnitude of V, and then sine of theta. That's the quick version. The longer version is just magnitude of U cross V, which is well and fine. That it would work, but I'd have to go and create my 2 vectors from what I have, and that's a task. I just wouldn't like to do that if I don't have to. Yep. And I'm going to just quickly flash the book to make sure I'm doing it right. They use R and F, U and V. Either way is fine, right? Cool. So we're learning together. Good to go? Awesome. Okay. Find the area of a parallelogram. So again, this is probably just geometry stuff, but if we can do the cross products and whatnot. So we got A. I'm just going to fictitiously, I think that's a word, make up my B, C, and D. I have no clue where, but I'm pretty sure A is right here because it's 0, 0, 0, thankfully, right? I need to find which one is opposite of A. And the reason why is because I need 2 vectors to make this work, do the cross product, and we're done. So like this one and this one, those are the actual 2 vectors that I need to find the answer. I don't need these. Yes? That's a method. I like that. That maybe takes a while. But you're right. If I went and found which one has the biggest distance, then I'd say exclude that dude, right? And just like randomly just looking at it. We got a 4, a 6, and a 5. We got the 6, so the 6 and 6 are covered. 4 is more than this, but 7 is more than 5. I think the squares of the bigger numbers are bigger, so like I would probably assume that this guy is the one that's further away, just as a guess. Therefore, you do not want this vector. You see that vector that goes out there? That's not part of the formula. So it's like just a wasted point. I would not use that. So I'm going to try. I might mess up, but I'm going to try by using these 2 and then these 2. I'm going to get rid of C essentially. Okay. So then my 2 vectors are super easy because obviously we had 0, 0 origin point. That's what I'm going to guess is going to work for me, okay? I don't know. If it starts messing up or I get something weird, I can go back and use the C point instead. But I'd rather think these are going to work. I think so. So yeah, y'all do it if you want, or I'm just going to do it up here for a little bit. 0. And I got a K. And I got a negative J. I'm not saying my notation is the best, but if you set it up beforehand, it does make it faster when you're doing numbers, you know? By no means am I perfect. By no means am I doing the exact right thing. But, yeah, you know, it works. 5 times 2 doesn't matter. 5 times 2, negative 10. Anything times 0, 0. 4 times 2, 8. 4 times anything doesn't matter, 0. 4 times 0, 0. 6 times 2, 12. 6 times negative 2, negative 12. And then it's again 0. I mean, look how fast it is. Once you got it all set up and it's happy, I wonder if there's like a way, and this is just me being silly, can you like make a stencil of this and just like spray paint it on your paper every time? You know what I mean? And then like then you got it, and then you just gotta fill in your numbers. Yeah. There you go. Yep. I still like my spray paint idea because it's and I'm done. But sure, or maybe like a big stamp, you know, kaboom. So looking at my letters and my numbers here, 12, 12, negative 18. Yeah, there we go. I want to find the magnitude of this. So the square root of the squares, and I'm just going to quickly do it in Desmos because it's way easier. Square root of 612. I'm curious what it is, but you don't need to. Yeah, okay. Good enough. I'm going to like flash right quick. I'm going to flash the instructor side. Let me just verify. We're getting the same thing. Yep, there we go. Sweet. There we go. Happy times. I'm really happy I don't have to simplify them things. And again, if you ever see like, oh, you need to simplify, you tell me, and I start slapping people. Not y'all. Pearson. Yeah. Right. Yeah. My math lab in general is very picky, but we've got a special compensation. Yes. Yes, we're special. Is that okay? Cool. Worked out. Again, I'm happy that I didn't have to use the C, and I chose that correctly. Just good this time. Determinants. All right. So this is not true. Move on. I am going to do 1 or 2 of them for you by hand, but I just for the fun of it, really. Remember, I haven't created the exams yet. I don't want this on the exams because you're only allowed scientific, and I'd like to do Desmos matrix with this. Does that make sense? In college algebra, if you had this, let's just say you didn't, but let's say you had this, you would have Desmos matrix. There would be no question about it. So same thing here. I do want to do it by hand because it's fun and it's interesting, but and it's cool for linear, right? A little bit of thought process there. But even in linear, you're gonna be using Desmos matrix. 100% sure on that one. I want to like. Okay. So let's do Desmos matrix. And I'm just going to show you how to do it. Very simple. First off, we need a matrix. So I'm going to put this stuff in. And this is how you should be doing your homework. When this comes up on your homework, use Desmos matrix, okay? Because it's not going to be on the exam because I can't let you have anything but scientific. Therefore, it doesn't make sense. Could it be on your final? Maybe, but like there's way better questions than this on your final. I ain't got time for this. But to do a determinant, DET, you can see there's a button there. You type it and you put an A in there, and you're done. That's literally how you get this problem done, and it's okay. Let me do the other one. So do a B, and there we go. There is actually really cool stuff going on here, but I'm just showing you how to get done with the homework, right? Get the answers. Everyone's happy. Let's move on. So determinants are an easy way to do cross products quickly. Know how I'm having to like stamp it every time and fill in the numbers? Well, this kind of would do the stamping for you in a way, if we are proficient with it. So let's just do this determinant right quick by hand. And I'm going to show you how it works. A 2x2 is incredibly easy, okay? We're going to simply multiply the numbers across from one another. So these guys right here, and these guys right here, and you multiply them. So you got 1 times 3 minus, always a minus, 5 times the negative 2. So you're going like, I want to like redo this and show you again. I'm going like this down, and I come around, and I come back down. It's kind of like the style of it. And there's like a minus in there. So simple. 3, 2 negatives make a positive, 10, 13. There's your answer. Very easy. I mean, if like, oh, look now, you should be able to do this on your exam. It doesn't matter. It's a silly question, right? It's just in here because we need to do it. But cool? Yeah. Determinants. Very simple. A 3x3 determinant, which is on the next page or whatever it is, it's right down there, that's a little bit longer. So we're going to break that one down for the fun of it, especially since we have linear folks here. It's great. Are you in my linear class? Are you in my linear class? I can't remember. No? Just y'all two? That's okay. It's great. So we're going to break it down. Because like this is on your chapter 3 quiz will be determinants. And you'll need to break it down and stuff anyways. Good with this? 3x3s. Here we go. So a 3x3 is more intense. Again, how do you do it over here? Very simple. You just do it. A 3x3, you put it in, and you're done. But I want to get the answer just to make sure I'm doing it right. But let's do the by hand process once so that everyone's happy. DET of C this time. There you go. So that side is easy. I'm not worried about it. Let's do the math by hand. To do this, we have to break it up into these things called, I think they're called co-majors. I'm not exactly sure on the names. It's a little weird. But what we want to do is split this thing up into 3 separate tiny determinants. And then we could do the tiny determinants, and then we're good. So let me use a different color. I'm going to call this column, I mean, you could choose any row or column you like, but I'm going to choose this one because it's super easy to do. These will be my majors, co-majors, something like that. But then their opposing numbers are going to be the determinant that I use for it. For example, this one here, I got a 1. I'm going to multiply it by this mini determinant. Okay, so that's the first level. We got 3 of them total, okay? Second one. I'm going to use this guy. Again, you have to use the same row or the same column as long as you're like going down, going across, whatever you want to do. So I'm going to do that. So now the thing is that you're going to have to do, it's a positive and it's a negative, but it's negative 1. We're going to have to see that here in a second. Times the determinant of its opposite numbers. So in this case, I got a 3, 4, and a 0, 1. And then the last one, we got negative 5. Now it's a positive again, yet negative 5. I'm going to explain the positive negative in a second. And then its opposites are up here. 3, 4, negative 4, 0. We scroll it over. We can't scroll it over. So there you go. So, and y'all can ask questions for sure. One of the things that I know you might be thinking is, why is it positive, negative, positive? a matrix that looks like this. And we don't look at it, but what I was using were these guys right here. Therefore, it's going to be a plus, a minus, and then a plus for our particular case, okay? You don't have to have that always. We just know that you alternate essentially. Especially if you're going down or across, these are the more common ones to use. So you just almost always plus, minus, plus. But I'm wanting those opposites of them. So again, you can see my orange and my orange, my red, and my green is kind of split, but there you go. I think it's called co-majors. Oh yeah, go ahead. So let's finish this one up. It's super easy to do these now that they're tiny. So the first one, again, I'm going to multiply and subtract them. So I got a positive 1 times, and then I got negative 4 minus 0. Because I'm multiplying them. This guy, 2 negatives now make a positive 1, and again, I'm multiplying like this again. So I got 3 minus 0. And then here I got a negative 5. And again, going across 0 plus 16. Because there's a minus already there. When you're multiplying it, 2 negatives will make a positive. Negative 4. Positive 3. What's 5 times 16? 80. And so, look, didn't we get it? Look at that. Oof. Takes forever. Now do it for a 4x4. And then that 3x3 you go down to a 2x2s. Oh man, it takes forever. Yes, terrible. So in our linear class, one of the ideas when we get to determinants is that you can break these down into triangular equivalents. So eventually you'll have blah, 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 and then 0, 0, 0. This one's way easier to do because if you choose these as your co-majors, and then there's your determinant, and it's like you're multiplying. You're literally multiplying 1, 2, 3, you're done. And it's so fast. But you have to actually change it to do that. Not today, not in this class. That's another day. So, but yeah, determinants are cool. It's just like, this is a really long, complicated process. I don't recommend it. Just use your calculator, of course. Cool? Now you've seen it. Now we're happy. Never see it again. Why would these be cool is if you go back up to the book, and I'm going to use the book as much as I can here. Did they have the cross product part here? Cross product with the determinants. Right here. Here it is. I, J, and K, they're not numbers, they're letters. So when you're doing this, you're actually doing like letters in your determinants. Desmos can't do that, but you can. And then it gets all kind of hair-wide crazy. But it works. That's just what they're saying is like an alternate version. Okay. We only got like 5 minutes. I want to start this though, and it's so fun. Don't you love this class? And it seems like, wow, Chad, we're already on section 5, and it's only the first week. I know, isn't it fun? This fun class. So I don't want to go too fast. I don't want to, but I'm telling you that this stuff is way easy now, and it gets way harder later. You're scared of triple integrals? Ain't nothing. We got way crazier stuff. So I want to go as much as I can when we can. Lines and planes. Let's just do some concepts for a minute, because if you look through this, we got formula. That one's easy. We've seen that one before. And then it just keeps moving. I don't even remember these formulas. I've never used them. They're asking it for, so I got them in there, okay? I'm not very keen on exactly how we're supposed to use them yet. But the concept is here. Lines and planes. So whenever we have a plane, each plane has a normal vector. And that normal vector is a line. So lines and planes are kind of connected with one another in a way, right? So like here, if you see that there, we can just draw a cool little plane there, and it's coming out from it. Whee! There you go. So they're all interconnected. they're wanting to do parameterization. That's a crazy word right there. We're trying to do parametric, which means we're going to use t values. And t values, t stands for what? What do you think? Time. So I'm going through time, trying to like weave through space. And so the complicated version would be you have a particle and it goes woo, and does that all over time, right? And you could say like t equals 1, t equals 2, t equals 3, t equals 4, and all that kind of stuff in order to find out where it is. Not here. That's too much. So we're just going to go straight lines. Whee! And t equals 1, t equals 2, t equals 3 as we go along. Okay? Cool. Well, every line needs a slope and an intercept. Yes? Look right here. We got t. There's our variable. This right here is our slope. And this is our intercept. Or initial point. Either way. And you just repeat. Yes? That's easy enough. So it's basically a lot of what we've already seen. We're just like mushing 3 of them together. Ha 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 ha. This thing, I have no clue. I haven't ever used it. We're going to figure it out later. This is where we're connecting the planes and the lines. Notice right here, this is actually a plane equation. Did they say it? Oh, it's a plane. There we go. This plane equation is super cool. I'm going to tell you right now, the A and the B and the C, I'm going to give you a name for them. Slopes. They're slopes. Not perfectly, but they come from the slope of the line that's determining the plane. I mean, if you're wondering about it, like here's your n vector, and n has 2, 3, 4. And if you want to make it all fancy from above, here, look, we're going to make it cool. Plus 5, 4t minus 7. The slopes are determining what the vector looks like. Cool. Well, this here, these are A, B, and C right there. So those are your slopes for the plane. Cool? They're all the same. They're all the same. And so that's how we're going to find the equation of a plane. So right here, looking at this guy, let me make my plane. You ready? 2x, 3y, 4z equals, I don't really know, that's whatever, but we'll figure that part out. But we got the slopes. Cool? Okay, awesome. This is just concept. I know we're leaving in a minute, but I just want to have some fun. Again, I don't know what that is. We've already seen this though, haven't we? Right? Angle between lines, angle between planes. Same thing. Planes, lines, same thing. It's just kind of a different way of looking at it. And then we can just go into this stuff. Because it's multiple choice, we can totally do this in just a second, right? The answer is A. I have no clue. But, I mean, if you look at it right quick, let's just look around for a second. We have this point, and we have this plane. What are these numbers right here? What did I say they were? They're slopes. They're slopes. So I'm looking for some slopes over here that match up. Do we see some slopes that have 7, 5, and negative 5? 7. We got 10s. So look, we got a 7. Look, that's next to a t, so that's a 5. And there it is next to a t, negative 5. Bam! I didn't even read the whole problem. Let's just check it though, Chad, okay? I don't really know if you're doing it right. It's B. So the bigger point though is that they're all interconnected. We just need to see what we're looking at, what the patterns are. Pop, 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 we're done. Cool? Okay, thank you very much, guys. Y'all have a great weekend. We don't have class on Monday. I'm putting on the recording, right? Class starts back up on Tuesday again.